Just like anyone can unmute themselves. Yeah, just remember anyone can unmute themselves and then just like shout out any answers when they want to. So, first of all, let's define a polynomial. Who wants to like try? Anyone? Isabel? No? Okay. So like a polynomial is basically an expression that's made up of terms with variables raised to like whole number powers and multiplied by like constants. Okay, let's play guess the polynomial. Like guess which ones are polynomials, okay? All right. Let's do first one is p of x. Can you guys see where I'm writing? Yeah. Okay. P of x is equal to x squared x squared plus 3x. Is that a polynomial? Type yes in the chat of yes and then yes. Yeah, that is a polynomial. Okay, what about this one? F of x is, let's say, x to the power of -1. Is that a polynomial? Okay, so that is not a polynomial. Right. Well, like x to the power of -1 is also just 1 over x, by the way. And then, okay, third one. What about g of x is, oh my god, g of x is equal to square root. I don't know how to do square root on laptop. Square root x. Is that a polynomial? No, that is okay. Pat Clam, do you wanna unmute yourself? Hello.
Yeah.
Yeah, is this a polynomial?
Well, uh,
Oh, that's great.
it's like option something.
Option. Okay. Yeah, thanks. Well, yeah, no, that is not a polynomial because for it to be a polynomial, it has to be like a variable raised to like a positive, no, a non-negative power multiplied by a constant. For example, like x to the power x squared, x cubed, and stuff. Yeah. What about this one? H of x is equal to e to the power of x. Is that a polynomial? Or let's change it up a bit. 3e to the power of x. Someone type in the chat. Yeah, no, it's not a polynomial. All right. Yeah. So you guys kind of get the definition of like polynomials now. All right. So raise your hand if you've done long division for like normal numbers before. Like, all right. Surely more than one person. All right. Yeah. So long division with polynomials is basically like the same thing, except this time you bring down like the terms instead of like the digits. All right. Does anyone know how to do long division with polynomials? Kingsley, do you know how to do it? Like if you do, you can unmute yourself and then you can try and explain. All right. Okay, I'll do it. It's fine. I'll do the example. Actually, the example isn't the best one to do. Just saying all of these problems have like a remainder of zero, so it says quotient and remainder, but it's just quotient. Okay. Anyways, my example is okay. Sorry, I'm writing on laptop, so my writing's gonna be really ugly. X to the power of 3 plus. Oh, this reminds me of differentiation. Minus 2x plus 1. This divided by x plus 1. So what you do in this case is like this is like basically the same as like long division with just integers, except this time it's just you've replaced it with yeah. So the first one is you just take a look at these first two terms, and then how many x plus 1s can you fit into x cubed plus 3x squared? Wait, Isabel, did you just write that? Okay. Anyways, yeah, x to the power of 2, and then you write it above the x to the power like this term. So x or x to the power of 2, x squared. So you go like that, and then you times these two together, just like a normal long division, and then you write it below this term. I mean, below these two terms. Okay? Okay. So it's like, what do you get after you multiply x plus 1 and x squared? Someone can type it in the chats. Yeah, x cubed plus x to the power of 2, x squared. So it's just you write it down here. And then you just do like normal long division, and then you take away this from the top one. So you get 2x squared, right? And then you bring down this term. So it turns into 2x squared minus 2x. So how many x plus 1s can you fit into 2x squared minus 2x? 2x, yes. So you go plus 2x. Does that make sense so far? Yeah? Yay. And then, oh, what the hell? And then you multiply these two this time. And then you get 2x squared. Ah, that's so ugly. Plus 2x. Okay, what's 2x squared minus 2x minus 2x squared plus 2x? This term can be negative, by the way. Minus 4x, right? So you bring that down, and then you go plus 1. All right. Now, how many x plus 1s can you fit into negative 4x plus 1? This can be negative. This number can be negative. Like, yeah. Yeah, negative 4. So now it's just negative 4. So it's negative 4x minus 4. Okay, can someone now tell me the remainder of this? Like what do you get as like the remainder? -3? Not quite, because you're taking away this from this, right? So yeah, it's 5. I probably should not put lines there, because that's really confusing. So after you divide this, so we know that after you divide this polynomial by this polynomial, you get this with a remainder of 5. Yay. Does that make sense? Can I have like a thumbs up if it makes sense? Yes? Okay. Cool. So now do you guys want to try the practice, and then I'll give you guys 3 minutes to yeah, no, 4 minutes until okay, 7:45 to do it, and then you guys can put your hands up, and then if you want to share. All right? All right, have you guys all tried the problems? And who's done the first question? All right, Isabel, would you care to share?
Okay. Wait, how do you write on this thing? Okay. Um, so x cubed, wait, I cannot write. Plus 4x squared
And like show us how you do it. Like don't just tell us the answer. Yeah.
Okay, Sophie.
Okay, Isabel.
Okay, so I first asked myself how many x plus 2 go into like the first term over here. And then it's like x squared. Whoa. And then I times it like Sophie told us to, and you get x cubed plus 2x squared. You can minus this and you
Maybe
get,
you put a line over here because it's kind of confusing.
oopsie, my bad. And then you can bring down the x. And then you can repeat the process. So how many x plus 2's go into 2x squared plus x? 2x can go into it, right? And then you can just also multiply it and get 2x squared plus 4x and then minus it, you get negative 3x over here, and you bring down the negative 6. And so how many x plus 2's go into negative 3x minus 6? Whoa, it's negative 3 and we don't have a remainder.
Yay!
A QED.
Cookies!
Yay.
Yay! All right. Yeah, that is how you solve the first first question. Would anyone like to attempt the second question? Guys, stop fighting over the cookies. If you solve a question, you can get cookies. Would someone like to attempt the second question? Don't be shy, please. Anyone? Wow. Okay. I guess I'll just do the second question. Isabel, do you want to do it again? No. Okay. I'll do it then. Let me just move your writing. Alright, second question is like, oh my lord, why is it that color? Oh, someone's writing an answer. Alright, let me just copy that. 2x cubed minus 3x squared minus 2x plus 3. Ow, my finger hurts. Over x minus. Okay, so first of all, how many x minus 1's go into here? 2x squared minus 3x. Well, like 2x squared, right? So 2x squared here. 2x cubed minus 2x squared. Oh my god, my handwriting is getting worse by the minute. And then what do you get after you take away this one from this one? Yeah, negative x squared, right? So you write that down here, and then negative 2x here. And then how many x minus 1s go into negative x squared minus 2x? Negative x, right? So it's negative x squared plus x, since negative 1 times negative x is positive x. So that then you get negative 3x, bring that here. And then it's negative 3, so yeah. Okay. But you might ask, what if like not every term is like included in the original like in the dividend? Wait, you guys know what the dividend is, right? Actually, no, I probably should write this out. I'll use like an example. It's just like the dividend is down here. I'll just use text. This is so hard. Dividend. What the hell? Why can I not make this bigger? Up here is like the up here is the divisor. Then now finally the quotient is here. So I'll be like referring to those like as we go on. And then as you know, like the yeah. And then as you know, the remainder is like the number we get after dividing. Yeah. Okay, so you may ask, what if like not every term is included in like the dividend? Like, for example, what if we divide, let's just say, I'm just making this up, x cubed minus x plus 2. Like, this is missing, this is missing like an x squared term, right? But we can still divide this. Okay, as a practice, divide this by x plus 3, let's just say. I literally just made that up, so like I don't know what the answer is. Yeah, I'll give you guys 1 minute to think about it, and someone can like share if they want to. All right, any thoughts or Anything? You guys can get cookies if you solve this problem or give me like any thoughts or anything. Yeah. Anyone? Just like unmute yourself if you want to talk. No? Okay. Well, no cookies, I guess. All right, let's move this. Because I'm just really not bothered to write that again. Well, normally what I would do is just leave a space for the x squared term and write plus 0x squared because that's essentially what it's saying, right? And then you basically just do the same thing. Well, Isabel, it's too late for you to get cookies, so like I ate your cookies, sorry. Yeah. And then the rest is just normal long division. I'm not bothered to do it again, so like you guys can just do it in your own time. The proof is left as an exercise for the reader. Ah. All right, let's move on to our next bit. Rational root theorem. Has anyone heard of the rational root theorem? Like, put your hands up if you've heard of. Okay, one person. That's great. So you guys have something to learn today. So the rational root theorem sort of helps us find possible roots of a polynomial. There's just not like guaranteed like a root for you. It's just they might be roots, you know. And you guys attended Isabel's number theory lecture, so you guys know like hi. You guys know stuff about number theory, right? That's can you just like type it in chat, please? Okay, so the rational root theorem is basically states, okay, if I write a polynomial like this, can you guys all understand? Like that? Is that good? No? Well, it's not really like an arithmetic sequence. It's like, okay, all right, let's not use A0, okay. So instead, let's use, okay, so x to the, oh my God. We all know that it's, a polynomial is like something times x to the power of n. Let's just say this is a times x to the power of n plus b times x to the power of n minus 1 all the way to like some random, well, not some random, but like all the way to the constant term, all the way to c. But then I don't like using the alphabet because there's only 26 letters in the alphabet. So like, yeah. And there's not necessarily 26 terms. So yeah, but like it's easier to understand this way. Um, so it's basically you can do it like that, all right? Yeah, Kingsley, what's your question or statement? Hello? All right.
The thing between the A and the X.
It's a times.
Oh,
It's,
like a dot.
yeah, it is a dot because if I use like times here, I'm gonna confuse it with the X, right? Because it looks a lot like the X. So in like Olympiad maths or like in just in math in general, like when you get into higher grades, we mainly use a dot instead of an X. I mean, a times, like Yeah, because it's easier to distinguish between an x and like the times thing. It's the same for 2 and z. Like I usually write z like that because otherwise I might mistake for like a 2. Yeah, anyways. Back to our topic. So it's basically like that, right? And then let's just say c is a constant term and a is the term of the like the c is a constant term and a is a coefficient, which is like the constant that is multiplied by x to the power of n, and n is like the number largest number, I guess, largest power there is in the polynomial. Okay, does that make sense? I feel like that might be a bit confusing. Can you guys give me like a thumbs up if it's like a yes? Or type in like the chat what doesn't make sense, because yeah. Otherwise I'm just gonna like assume that you guys are comfortable with it. Alright, okay. Oh my god. Well, this is like an important concept while using rational root theorem, because it basically like involves the using the coefficients. So the rational root theorem basically states that, let's just say there is a root of a polynomial p of x. Oh, well, like okay. Let's just say there is a rational root of the polynomial p of x that has all integer coefficients. Okay, if it doesn't have integer coefficients, then that's not gonna work. All right. Let's say one of the roots of p of x is p over q, where um where p and q are like in its like lowest terms, if you if that like makes sense. Like this cannot be simplified further, and also p and q must be integers. That's like really important. For using the rational root theorem, we know that p divides c, which is the constant term, and q divides a, which is the coefficient of the leading term, which is like this term. All right. And then from there you can find all possible roots. Yeah. Does that make sense? I feel like I'm going really fast and like yes, no, maybe. Can someone like please react, because this is really scaring me. Well, Isabel says yes, but like maybe. All right. So what doesn't make sense? Like, can you guys type in what doesn't make sense so I can explain that bit maybe like a bit further? Otherwise, if you're fine with the concept, turn the page. Oh yeah, guys, you guys can turn the page on this, by the way, if you didn't know. There's like a page turn button on the document thing. Turn the page to the second page. Ah, why is it writing on this? And then you can do the example problem. Actually, no, the example problem already has stuff in it. Actually, yeah. Do the practice problem 1. There's like a arrow button on top of the thing. Yeah, that. I can just screenshot it and put it in here. I've screenshotted it and put it above the document. You guys can try to do the problem, or you guys can type like any questions, comments, statements or stuff in the in the messages thing. Yeah. All right. Does anyone have any ideas or like thoughts? Anything? Isabel, would you like to unmute yourself or type something in the comments? If you type something in the comments, then I'll give you 30 seconds.
Okay, cookie time. So
I'll
basically,
give you cookie if you do it like correctly.
oh, okay. So basically, the a term of like this polynomial, it's just one, right? Because it's 1 times x cubed basically. And then the last term is -2. And then if we look at the possible factors of 1, it's just plus minus 1. And then for -2, it's like plus minus 1 or plus minus 2. And then since it's like P over Q, then it's like plus minus 2 over plus minus 1 or plus minus 1 over plus minus 1. So the possible solutions are plus minus 1 or plus minus 2, right? Did I do it right? Do I get cookies?
Yay!
Yay!
You get cookies. Let's let's grow our cookie amount exponentially. Just like 5. Okay, that's 25 cookies for you. All right, as you can see, guys, if you do a question correctly, you get cookies. So, yeah, please do questions. Anyways, that is correct. And yeah, let me just make this smaller. So, would anyone like to attempt? Oh, how much time do we have? Let's actually go on to the factor theorem and remainder theorem for now. Because, like, the practices for, like, rational root theorem are basically the same. All right, factor theorem and remainder theorem. Well, let's just say remainder theorem is like a more generalized factor theorem. But let's just explain factor theorem first. Thanks, Kingsley. But like your cookies aren't as valuable as my cookies. Okay, so
Copy the cookies from your message.
well that's still your cookies. Okay, anyways, factor theorem. So we have this polynomial p of x. And we know that if P of A is equal to 0, so like if you sub in P of A and it is equal to 0, then x minus A is a factor the um of this polynomial. So basically what it's saying is like if you divide the polynomial by x minus A, then you will get a remainder of 0. Does that make sense? Yeah. And then, but you might ask, like, how do I find the remainder of, like, how do I find if P of A is equal to 0? Does anyone have any ideas? No? Okay. So, mm, no, that's not really why I'm asking, but that is like a good point. Like try rational roots. That is kind of like how you find the A. But like assuming we know the A in a problem, how do you find out the value of the polynomial when it's like P of A? So let's just use the polynomial from page 1, question 2, which is okay. I'm just gonna copy and paste this because not bothered. Thanks to whoever did this brackets thing, by the way, very helpful. But like, I kind of don't want it right now. Okay, so it's this, right? I'll make it big, and then so P of x is equal to this. And assume we know that 1 is a root of this. How do we find out if 1... well, let's just say the question asks you to find like the remainder of like... I don't even know. I don't know. Well, let's just say the question asks you to check if x minus 1 is like a factor of the polynomial. What would you do? Well, like using factor theorem, we know that if P of 1 is 0, then x minus 1 is like a factor, right? So yeah, you sub in 1 into P of x. So P of 1, so you change all the x's from this equation, or not equation, expression into 1s. So what's 2 times 1 cubed? You guys should be able to do this. Wait, 2 times 1 cubed minus 3 times 1 squared. Oh, that looks like 301. Minus 2 times 1 plus 3. If you guys can't do this, then you should not be here. Can someone give me an answer to this? Yeah, it's 0, right? So since that's 0, so we know that 1 is 1 is a root of the polynomial, and therefore x minus 1 is a factor. Does that make sense? Thumbs up if it makes sense. Yay. Okay. Okay, so like factor theorem makes sense. Now time for remainder theorem. Remainder theorem is basically just like same thing, except it's more generalized. So say we have... So instead of using long division to find the remainder, you can just use remainder theorem to find the remainder. So say we have like this polynomial P of x, and then you can, and then the question asks you to find, let's just say, and then it's just like, the question asks you to find the remainder after you divide the polynomial P of x by x minus a. Well, what you would do is you would sub in a into every place that has an x, and then you add it up, and then you get the remainder. If that makes sense. Let's do an example, because let's just do the example that's on the sheet. Sorry, I'm kind of lazy, so not bothered to like. Yeah. What's the example? Find the remainder when this function is divided by x minus 2. Well, we know by remainder theorem, if you plug in f of 2, then you get the remainder, right? Because that's like what remainder theorem basically says. So we can just do f of 2. What's f of 2? Someone can write it out here. I don't care who. Well, okay. No one? If you write it out, then you get cookies. Wow. No one wants cookies. Alright, I'll just eat the cookies then. Oh, yay. Wait, I can't actually see who writing. Kingsley, yeah? Do you want to unmute?
Hello, can I
Hmm?
remove this?
Wait, what? Which one?
This.
What,
I
what
typed
you
the better one.
Sure. Wait, who's actually writing? I actually can't see. Yeah, and then you can just calculate this. It's just 8 plus 8 minus 2 plus 4, which is equal to 18. Yay! Alright, cookie time. Exponentially growing cookies. Yes, that is 125.
So that means next time it will be
Next time it will be 625.
5. And then after that it will be
Oh, 5 to the power of something. Like 5 to the power of
then 20.
5. Next time it's gonna be 5 to the power of 5. Can't calculate that.
And then it will be
5 to the power of 6.
15,625.
Okay. So do you guys want to try the practice questions, and then there will be cookies up for grabs again? I'll give you guys until 8:20 to do as much as you guys can.
What?
Up until 8:20.
To do what?
These questions, I'll paste it here. Kingsley, you can screenshot a better screenshot if you want, and then you can like, yeah, take it out.
Let me cook.
Actually, I'll give until 8:21. All right. Does anyone want to attempt any of the three questions? You guys can do 1, 2, or 3. It doesn't matter. Oh, wait. Wait, why'd you replace it with the rational root questions? Excuse me? It's these questions. What the hell? Oh yeah, those questions. Hello? Yeah. Does anyone want to try any of these three questions? And you're just show working to get cookies, because cookies won't just appear, they like, you know. Okay, Isabel, you can explain. Unmute. Isabel.
Wait, I'm pretty sure someone already got question 1. They can explain.
Okay. Oh, who is this? Okay, who wants to explain question 1? And not just like give me an answer. Can you guys just unmute or like type in chat? If you guys are gonna type in chat, can you just like let me know? So I don't just like wait here.
You can substitute positive 2 into the function.
Yeah, that's right. You just substitute positive 2, and then you use your very cool arithmetic skills, and then you calculate it. You basically just go 2 squared minus 3 times 2 plus 5, which I trust is 2. I mean, not 2, 3. Right. Kingsley, too late, sorry. You can do question 2 if you want to. Alright, you can get cookies. Oh no, it says it's over the thingy. Oh, okay, I can only give you 125 cookies. Because the factor theorem says that like if not factor the remainder theorem says like if you substitute like f of a into the thing, then you get the remainder. Then you get the remainder when the polynomial is divided by x minus a. Well, yeah. Well, that's like what you just typed in chat is like for the factor theorem, but for the remainder theorem it's basically the same thing, except like you don't get 0, you get like the remainder. Wait, Kingsley, is it the second question?
And if you get if you get a value of 0, then the remainder is 0. It's a
Yeah,
factor.
well, like if the remainder is 0, then that's basically just saying it's a factor, right? Yeah.
Yeah.
Oh my god, that's a lot of cookies. Alright, I trust that this is correct. -2. Can someone calculate this for me? -2 minus 3 minus 1. Yeah, that's right. Kingsley, you got cookies. Yay. Alright, does someone want to try question 3? And why is question 3 like kind of rubbed out? That's very sad. What is it supposed to say? Hello? Oh, x minus 1. Alright, you guys can attempt this question. And I would prefer someone who hasn't spoken or hasn't done any problems yet to like try, because otherwise the people who have gotten cookies would get a sugar rush. Anyone? Can you show your working, please, Chris? 1 minus 1 plus 2 minus 1. Yeah, that's... Wait. Wait. Oh, wait. Oh, wait, yeah, that's right. Sorry, I'm just tripping. Chris, if you show you're working, then you get fully baked cookies. Otherwise, you just get like... Yeah. Yeah. Yay, cookie time. All right. That's basically all the information you guys need to know today. You guys, since we have like 5 more minutes, do you want to just do the first question? Well, actually, can we vote? Can you guys type in chat which question you want me to go through with you today? Like, challenge problems? Question 1, 2, 3, or 4. And then we'll go through that one. Anyone? Just like... Okay, I'll do the problem like the first like one that like, you know. Any is good. All right, I'll do first question then. Use the rational root theorem to list all possible rational roots, then test them to factor the... Oh, I don't want to bash. It's fine. I've bashed way more than this, so it's fine. So, can you see where I'm writing? Okay, use the rational... then... Okay, so the rational root theorem says like the possible roots are plus minus 4 over plus minus 1 plus minus 2 over plus minus 1 and plus minus 1 over plus minus 1, right? So all the possible roots are 4, negative 4. Why did that turn up as a dollar sign? 2, negative 2, and 1 and negative 1, right? Oh. Okay, so how do we test this? We can just use factor theorem or remainder. We can just use factor theorem, right? So like, if they are a root, then technically, if we plug this into f of x, then then it should come up with like 0, right? So can someone test like some, and then I'll test the others because we only have like 1 minute left. Actually, it's fine. Let's test it together. So let's test 4 first. 4 first, like what do we get when we plug in f of 4? What's the answer? Like, okay, Isabel. So what do we get when so what's f of 4? It's just 4 cubed plus 4 squared minus 4x minus 16 minus 4, right? And then that's like definitely greater than 0, because just like using my intuition. So that's greater than 0, so therefore it does not work. Negative 4, then that's just negative 4 cubed plus 16 plus 16 minus 4. And then that's also just not 0, I think. That's also just not 0, so that doesn't work. Well, there's people saying that 2 works. Right, let's test out 2 now. Well, let's just cross out 4 and negative 4, because those 2 can die. F of 2 is just 8 plus 4 minus 8 minus 4, right? And that's definitely equal to 0. So we know that 2 is a root. Yay. Now, since it's a cubic, so there must be 3 roots. So yeah. Well, they might not all be rational, but yeah, anyways. Let's test out negative 2 now. Negative 2. It's equal to -8 plus 4 plus 8 minus 4. That's also equal to 0. Isabel, I'll give you cookies later. So yay, that's another root. Right, let's speed run the last two because like you guys have to go. F of 1 is just equal to 1 plus 1 minus 4 minus 4. That's not equal to 0. And then f of -1 is just equal to -1 plus 1 plus 4 minus 4. And that is equal to 0. So, yay, we found all three roots. Yay. Okay, I'll give Isabel some cookies now. Isabel, your cookies are on the screen. On the whiteboard thing. Yeah. Okay. Thank you for listening, guys. If you guys have any questions or if you want to send like solutions to the problems to me, then just email me. Oh, I'll just write my email again. 51046 at Kristen dot school. Oh my god, dot NZ. There. I think that's right. There. Anyways, thanks for coming, guys. Next time we're gonna learn about Vieta's formulae and applications. Thank you. Good night, guys. Yay.